Chapter The Earth Structure. In this chapter, we'll be covering total of 27 questions. It's a limited size chapter, but it is a chapter which makes your base, as well as it has picture study questions. Let's see the syllabus, what you're going to cover. You're going to cover about the core, the mantle, and the crust. The three layers: core, mantle, and the crust. You're going to cover its meaning, extent, and their composition and characteristics. Let's see the introduction. It's the first two questions of the chapter. It says the first question: name the sources of information about forces operating inside the earth. So, how do we come to know about what is happening inside the earth and what are the forces operating inside the earth? So, it says our knowledge about the interiors of the earth does not come from excavations and explorations of the interior parts of the earth, but the study of seismic waves, materials thrown up by volcanoes, and the evidences from the theories of origin of the earth. So it says a knowledge which we get about the interiors of the earth, whatever the earth is made up of, does not come from excavations and explorations. Excavations, digging, and exploration does not give us that information. But how do we come to know how do we come to know what is there in the interiors of the earth? It comes from the study of seismic waves. Seismic waves means earthquakes. Seismic waves means earthquakes and materials thrown up by volcanoes. So earthquakes and volcanoes tell us what the earth is made up of. We also get to know about the theories of origin of the earth. We also get to know about evidences from the theories of origin of the earth. So three things: how do we come to know what the earth is made up of? Earthquakes. Earthquakes is also called as seismic waves. Materials thrown up by volcanoes. Earthquakes and volcanoes are there in your grade 9 syllabus as individual chapters ahead. And it also tells you about evidences from the theories of origin of the earth. Second question: how do meteorites help scientists know about the interiors of the earth? So it says at the time of origin of the earth, that is, the every planet and meteorites which were floating in space were made out of the same material. So the scientists can calculate the composition of rock of the earth, that is what the earth is made up of, by studying the materials which are found in the meteorites. Why? Because meteorites and the earth is made out of the same material, because eventually everything is a part of space, and meteorites as well as planets including our earth is a part of the solar system. Moving to the second part after introduction is structure of the earth. Question number 3: the earth is made up of several concentric layers, name them. The earth is made up of several concentric layers, which are: the outer layer of the earth's crust is known as the lithosphere. The outermost layer of the earth's crust, where you and I live, is known as the lithosphere. Litho means rock. So this is basically the land, this is the rock surface. Part of the earth's crust that are immersed under oceans and seas, that is underwater. The land which is under water is called as the hydrosphere, and extending upwards, the earth is enveloped, that is covered by a blanket of gases which makes up the atmosphere. So to revise, the structure of the earth is made up of concentric layers, There are three of them: lithosphere, which is land, hydrosphere, which is water, and atmosphere, which is gases. Now moving to the third part of the chapter, that is after introduction, structure. Now we see composition, that is chemical composition. Now under chemical composition, we will mainly be composition and chemical, any kind of composition. We will mainly be focusing on the lithosphere. Why the lithosphere is because, as the name of the chapter suggests, structure of the earth. We are mainly going to speak about the land and what the earth is made up of in the interiors here, and we are going to mainly focus about on the rock part, that is the lithosphere. Atmosphere and hydrosphere will be coming ahead in your syllabus. Let's see question number 4. What is the lithosphere and explain its chemical composition? And a very important answer, which is a sure shot, distinguish between Sial and Sima. Let's see what is the lithosphere. The meaning: the crust of the lithosphere is the outermost layer of the earth. Lithosphere is taken from the Greek word lithos, which means rock. It is the thinnest layer of the rock enveloping the interiors of the earth. It is made up of which rocks? It's made up of rocks. We have given a short form FMS, FMs, feldspar, mica, and silicates. So revising these 2 points, it is the outermost layer. Lithos is from the Greek word meaning rock. It is the thinnest layer, and this rock content is made up of feldspar, mica, and silicates. What is the composition of the lithosphere? The lithosphere can be divided into 2 broad divisions, Sial and Sima. Sial and Sima is a very important answer. They can ask you only one, that is either only Sial or Sima, or a distinguish. Let's see the first point, Sial. It appears to float above Sima. Sial is above Sima. This is because it is less dense. It is thicker over continents, but thin or absent on the ocean floor. So revising key terms, Sial is above Sima because it is less dense. It is more thicker over continents and absent over ocean floors. If you know the first point of Sial, you will know the first point of Sima. So Sial is above, Sima is below. It appears below Sial. So Sial is on top, Sima is below. Sial is less dense, Sima is more dense. Sial was over continents and thin or absent over ocean floors. Sima makes up the ocean floors. The main mineral constitutes are, so the name comes from Si. Si comes from silica, and here Al makes up aluminium, and here Mg makes up magnesium. So Si stands for silica, Al stands for aluminium, that gives you Cl, and Si stands for silica again, and Ma, actually it's written as Ma, but Ma is magnesium, which is Mg, thus it is Sima. And the fifth question under chemical composition, In which part of the earth is NiFe found? What is it composed of? So NiFe is found in the interior or inner core of the earth. Inner core of the earth. This is of the inner core of the earth. Ni stands for nickel and Fe stands for iron. Moving to the fifth question and the last question under chemical composition. In which part of the earth NiFe is found? What is it? What is it composed of? So NiFe is found in the inner core of the earth. This is of the earth, inner core of the earth. Ni stands for nickel. Fe stands for iron. And these being heavy metals have high density. Heavy metals, high density. That's why they are found deep inside the earth. Moving to the fourth part of the chapter, that is after introduction, structure, chemical composition. Now we do internal composition. So name the layers the Earth's interior is made up of. You've already done it before. Based on the above chemical composition, the interior of the Earth is divided into core, mantle, and crust. Here is the image. You've done this before. Structure of the Earth, core, mantle, and crust. Let's speak about the core now. Meaning, the core of the earth is the most inaccessible part of the earth. Give reason. They can ask you the meaning of the core, or they can ask you that the core of the earth is the most inaccessible part of the earth. Give reason. Three simple points. There are four core layers of the earth, which you've already done: the crust, the mantle, and the core, which is divided into the outer core and the inner core. These are the four main concentric layers: crust, mantle, outer core, inner core. Moving to the second point, the core of the earth is the last layer and it is inaccessible from outside as it lies thousands of kilometers deep inside the earth. And the third one, the earth's core is responsible for the magnetic field that the earth possesses. The outer core is in liquid form, whereas the inner core is in solid form. Let's revise the meaning of the core quickly. The main layers of the earth are the crust, mantle, outer core, and inner core. Point number two says that the core of the earth is the last layer. It is the inaccessible layer as it's going from the outside. It lies thousands of kilometers deep inside the earth. The core of the earth is responsible for the magnetic field that the earth has. The outer core is in liquid form, whereas the inner core is in solid form. Question number 8. Which layer is responsible for the Earth's magnetic field? Why? Very important. They do ask you about the Earth's magnetic field in every question paper. It's a short answer. Let's see what does it say. The core of the Earth is responsible. The core of the Earth is called NiFe, where Ni stands for nickel, Fe stands for iron. It is believed that iron and nickel is responsible for the Earth's magnetic field. The magnetic field is oriented mainly towards north poles and south poles. So which layer is responsible for the Earth's magnetic field? The core is responsible for the Earth's magnetic field because it has iron and nickel, and the magnetic field is mainly oriented towards north pole and south pole. This question number 8 is very similar to question number 5, which you had done. 8 and 5 are very similar, which both speak about nickel and iron and having the magnetic field, and iron and nickel being heavy metals. You had already done this in question number 5. Have high density, that's why they are found deep inside the earth, that is in the inner core. Moving to extent, what is the extent of the core? Question number 9. The entire core is about 7,000 kilometers in diameter, which is more than half the Earth's diameter. 7,000 kilometers in diameter, which is more than half the Earth's diameter. And the core is divided into outer core and inner core. Composition. Question number 10 is a give reason, very important. The inner core of the Earth is in solid state. Give reasons. So the inner core is in solid state, give reasons. And you've already done that. And the inner core is in solid state here, whereas the outer core is in liquid state. 3 simple points. First one, the temperature ranges from 4,400 to 6,000 degrees Celsius, which is very hot. Second one, you've already done the second one as well. Since iron and nickel are heavy metals, having heavy density, they are found deep inside the earth. Third one, the solid state of the inner core is due to the high density and pressure which have compressed the molten rock material. The rock material, molten rock material, despite it being so hot, there is high density and pressure which has compressed the molten rock material. So this molten rock material has been compressed together despite temperatures being hot. Compression has happened, and that's why the inner core is mainly in solid state. S waves disappear in the outer core, which suggests that the outer core is in molten state. Revising question number 10, the temperatures of the core are from 4,400 to 6,000 degrees Celsius. The core has heavy metals, Ni and Fe, nickel and iron. Being heavy metals, they have high density and they are found deep inside the earth. And the solid state of the inner core is due to this high density and pressure which have compressed the molten rock material. And the outer core is in molten state because of the presence of S waves. Moving to the second layer after core is the mantle. Question number 11, describe the mantle and its 2 characteristics. Let's see where the mantle is. This diagram once again. So you did the inner core, you did the outer core. Now we see the mantle. This is the mantle. 3 points again for the mantle. The mantle is the middle layer of the earth. Mantle is the middle layer of the earth's interiors. It is also known as mesosphere. It lies below the crust. It lies below the crust and above the core. Second point, the movement of the mantle. So the mantle moves is the reason that the plates of the earth move. And the average thickness is 2,900 kilometers of the mantle. It is 2,900 kilometers thick and makes up 84% of the Earth's total volume. It's a very thick layer. It makes up 84% of the Earth's total volume. The mantle, just like the core, is also divided into two parts. The mantle is divided into two parts, that is the upper mantle. Here it is based on little figures, you'll have to learn it. The upper mantle extends from Moho discontinuity. So we are going from up to down. It starts from Moho discontinuity up to a depth of 700 kilometers. So Moho discontinuity says 700 kilometers down. And from 700 kilometers to 2,900 kilometers down is the lower mantle. The upper mantle is cooler and is made up of solid rocks. The lower mantle is hotter and denser than the upper mantle. Quickly revising the 2 points of the mantle, the upper mantle goes from Moho discontinuity to 700 kilometers. The lower mantle is from 700 to 2,900 kilometers. The upper mantle is cooler, the lower mantle is hotter and denser. After the mantle, we learn about the asthenosphere. Where is it formed and in which form does it exist? Where is it found and in which form does it exist? At the depth of around 100 to 410 kilometers, the mantle is partially molten and is known as the asthenosphere. So part of the mantle is asthenosphere, which is 100 to 410 kilometers के बीच में. It is partially molten. Now, this is a very interesting and important question. The asthenosphere is in semi-molten state. Give reasons that it is semi-molten. That means it's semi-solid. So at the depth of 100 to 410 kilometers, the mantle is partially molten, which is known as the asthenosphere. It is due to the temperature, which is around 1,100 to 3,700 degrees Celsius, along with great pressure and density. A very simple one marker. Asthenosphere is semi-molten. If to say the extent, it is 100 to 410. If to mention it's a part of the mantle, it's partially molten. It is due to the temperature, which is 1,100 to 3,700 degrees Celsius, along with great pressure and density. Here you can see a picture, ocean, lithosphere, and below the lithosphere, which is a part of the mantle, it's a part of the upper mantle. The upper part of the upper mantle is the asthenosphere. Semi-molten, that is semi-molten means semi-solid. Moving to the next layer, Gutternberg discontinuity. I'll show you the image also of the Gutternberg discontinuity. The boundary between mantle and core. So we finished two layers. We did mantle and we did the core. The innermost was the core. Above the core is the mantle, which is the middle layer. M for mantle, M for middle. So the boundary between the core and the mantle, it is also called as the mantle-core interface, is known as the Gutternberg discontinuity. Let's see this with the help of the diagram. This is a diagram which is there in your chapter. It's the last question of the chapter. You did the core, you did the mantle. Now, here is the Gutternberg discontinuity. That is the layer which separates the core from the mantle or mantle core interface is known as the Guttensberg discontinuity. Whereas 4 points, we did the first one, mantle core interface is known as Guttensberg discontinuity. Continuing, point number 2, it begins at a depth of 2,800 kilometers. Third one, here there is an abrupt change in the seismic waves generated by earthquakes or explosions that travel through the earth. P waves, called as primary seismic waves, decrease in velocity, while S waves, that is the secondary seismic waves, disappear completely. And last point, it is dense, probably due to greater percentage of iron. So revising the 4 points of Guttensberg discontinuity. First one, meaning, inside the meaning, the boundary between the mantle core or the mantle core interface is known as the Guttensberg discontinuity. Out of the 3 points are very simple. It is found at the depth of 2,800 kilometers. And lastly, it says greater percentage of iron is here. The third point, which is a little different one, how do you come to know that there is a layer or there is some kind of discontinuity, as the name says? How do you come to know that there is some kind of change? It is because here there is an abrupt change in the seismic waves. These seismic waves which an earthquake or an explosion gives, these waves which come, there is a change in these waves. P waves, as the name says, primary waves decrease in speed, that is velocity, whereas S waves, that is secondary seismic waves, will completely disappear. Hence, because of this abrupt change, we come to know that there is some discontinuity or there is a shift from mantle to core. And here the shift begins, here the core and the mantle shifts. Because there is a change, there is an abrupt change. Once again, P waves become slower, velocity, S waves completely disappear. Moving to the final layer, that is the outermost layer, which is the crust of the lithosphere. We will see it in this picture. So after the core, the mantle, we do something called as the lithosphere, that is the crust. Question number 16 and 17, the crust is called as the lithosphere. Explain or give 2 characteristics of the lithosphere or the crust. 4 points. The first one, the crust of the lithosphere is the outermost layer of the earth. Lithosphere is come from the Greek word lithos, which means rock. These points you've already done. Point number 2, the crust is only 1% of the Earth's mass and contains all known life in the universe. So every life which survives is the part of the crust. And it is only 1% of the Earth's mass. Third point, the crust is the thinnest layer of rock enveloping the interiors of the Earth. And finally, fourth one, considering the size of the Earth, the crust is relatively thin layer of rocks, 1% thinnest layer, with a thickness of 60 kilometers below the high mountains and just 5 to 10 kilometers below the oceans. So very thin layer, 60 kilometers below the high mountains. So mountains, 60 kilometers, and below the oceans, it's just 5 to 10 kilometers. Revising quickly the keywords, the crust is also called as the lithosphere. It is the outermost layer, comes from the Greek word lithos, meaning rock. Second point, it is 1% of the Earth's mass and contains all life in the universe. Crust is the thinnest layer of rock, and considering the size of the Earth, the crust is very thin layer with thickness of 60 kilometers below the high mountains and just 5 to 10 kilometers below the oceans. Moving to what is the composition of the Earth's crust. 3 points. The Earth's crust is composed of various types of rocks. The temperature of the upper part of the oceanic crust has been estimated at 0 degrees Celsius, but it gradually starts rising as you go towards the interiors. So the first point says the Earth's crust is made up of various types of rocks. You're going to study types of rocks in the next 2 chapters as well. The temperature of the upper part of the oceanic crust is estimated at 0 degrees, and as you go below, temperature continues to rise. The weight and pressure of the rocks also start increasing with depth as you go inside. The weight and pressure of the rocks keep on increasing. That's what you did in the core and the mantle also. And the composition of the Earth's crust also contains oxygen and silicon. Question number 19. Why does the Earth undergo many changes? Again, 2 points. The crust of the Earth undergoes many changes because of the heat and pressure. Mainly, the crust of the Earth is formed because of rich igneous rocks like basalt and granite. Second point, it is because of the fact that most of the abundant rocks that form the Earth's crust are igneous. They are formed by cooling of the magma. And secondly, besides, metamorphic rocks undergo drastic changes because of excessive heat and pressure. Moving to the last layer, Moho discontinuity. Just as the Guttensberg discontinuity, we do the Moho discontinuity. The discontinuity between the crust and the mantle is called as the Moho discontinuity. So between the core and the mantle was Guttensberg. Between the crust and the mantle is the Moho. We'll see the image also. This discontinuity was discovered by the Yugoslavian scientist Andrea Mohorovicic in 1909, hence it is known as the Moho discontinuity. Let's see the Moho discontinuity in the image. So we take it from the top, you did the core, and between the core and mantle is the Guttensberg. Then you did the mantle. Now the discontinuity between the mantle and the crust is the Moho discontinuity. And then we did the crust as well, which is the lithosphere. So the discontinuity between the crust and the mantle is called as the Moho discontinuity. Let's see the question number 21. Explain this Moho discontinuity. So the Moho discontinuity forms the boundary between the crust and the mantle. Like the crust, it does not exist at uniform depth. There is no uniform depth. It is found at 8 kilometers beneath the oceans and 32 kilometers beneath the continents. So underwater and under land, it is varying. More discontinuity under oceans is 8 kilometers and under land it is 32 kilometers. It has the characteristics of both these layers, that is, it has the characteristics of the crust and the mantle, the crust and the mantle, because it is the boundary between the crust and the mantle. Rising boundary between the crust and the mantle is called as Moho discontinuity. It does not exist at uniform depths. Below the oceans, it's 8 kilometers. Below the land, that is continent, it is 32 kilometers. And it has both the characteristics. It has the characteristics of both layers. That is the upper layer, which is the crust, and the bottom layer of the mantle. Question 22. Right, one difference between the Moho and the Gattonsburg discontinuity. The Moho discontinuity is the boundary between the crust and the mantle, and the Gattonsburg discontinuity is the boundary between the mantle and the core. 22 and 24 go together. There are two transitional zones between two consecutive layers of the in the interior of the Earth. Name them and explain their characteristics. So here as well, we are speaking about the Moho discontinuity and the Gattonsburg discontinuity. These are the two transitional zones. They tell you transition between core mantle and crust. So the transitional zone between the crust and the mantle is called as the Moho discontinuity, which is dividing zone between solid and semi-solid state of rocks due to increasing temperature as the depth increases. Between the crust and the mantle, Moho discontinuity, it is the dividing zone between solid and semi-solid state of rocks. Solid and semi-solid state of rocks. It is due to increasing temperature as the depth increases. And the boundary between the mantle and the core is known as the Gattonsburg discontinuity. Below this zone, both density and temperature goes on increasing. So as you go from the Gattonsburg, that is as you go from mantle to Gattonsburg, and from Gattonsburg to the core, as you go towards the core, obviously what will happen? Density and temperature both will increase. And the density is more than 13 and temperature is more than 2200 degrees Celsius, because as you go towards the core, both increases, that is temperature increases as well as density increases. Moving to question 23. What are the consequences of the pressure and temperature in the interiors of the Earth? Interiors of the Earth, what is the pressure? What is the temperature? This has a little figures, so you'll have to learn them. Due to extreme temperature of 2200 degrees Celsius, every matter is in liquid and gaseous state in the interior core. So in the interior of the core, everything is in solid or liquid state because the temperatures are very high, 2200 degrees Celsius. So everything is in liquid or solid, gaseous state. So after the core, we go to the mantle. The temperatures here are from 870 to 2200 degrees Celsius. And here everything is in semi-liquid to liquid state. So core temperature was 2200, mantle is 870 to 2200. Here core may everything was in liquid and gaseous. Here it is semi-solid to liquid. The crust, which is a layer of 60 kilometers beneath, 60 kilometers in breadth, is made up of solid rocks. And here the density, here they have given you the density. The density is of 2 to 3 grams per cubic centimeter. This is grams per cubic centimeter. And the density goes on increasing from 2 to 3 to 3 to 4 in the mantle and 10 to 13 in the core. So revising the density in the crust, which is the outermost, is 2 to 3. Mantle mate becomes 3 to 4 and core mate will become 10 to 13 grams per cubic centimeter. Moving to the last three questions of the chapter. 25. Temperature starts rising gradually towards the interior of the earth. This answer is repeated, so I'll write an R here. Due to enhancing density and pressure, the temperature goes on increasing gradually towards the interiors of the earth. So as you go towards the interiors of the earth, temperature and pressure goes on increasing. 26. Last theoretical question. What part is suitable for human habitation? Why? The outer part of the earth, which is the crust, is suitable for human habitation due to favorable conditions. That is, because of the presence of atmosphere, that is air, lithosphere, that is land or rock for settlement, and due to ideal temperatures on this land, and hydrosphere, which is water, hydrosphere for hydrological cycle, that is the water cycle, for providing rainfall and fresh water, bodies on the earth, and oceans for navigation and trade routes. That's why where do we live, which is the most suitable part for human habitations, is the outer part of the earth, that is the crust. And the last question, which is the diagrammic question. This is a very important diagrammic based question. Draw, it can come for drawing or labeling. You have already labeled most of them and drawn most of them. When you do this in the exam, or when you get this in the exam, make sure you take a compass with you, geometry box, because you will have to name. Number one, we'll go from inside to outside. You will do the core naming. Then you will name the Guttensberg discontinuity, which is the core mantle interface. Then you will name the mantle. Then you'll name the Moho discontinuity, which is the mantle and the crust interface. Then you'll name the crust, which is the lithosphere. And finally, ocean, that is the water, and atmosphere, that is the gases layer which envelops the earth. In picture study, before we wind up, this image can also be shown, which you've already done for picture study, which is the asthenosphere, question 13 and 14. This is the ocean. Below is the ocean, is the lithosphere, and below the lithosphere is the asthenosphere. This is the crust, which is the part of the land crust and oceanic crust. Here, land crust and oceanic crust, volcanoes and lithosphere. This is called as the asthenosphere diagram. And this first page, this was as well there, which can come for naming or drawing. Inner core, outer core, mantle, crust. Very simple. This is called as the structure of the earth. This winds up your chapter, Earth structure.